Hello and welcome to today's lesson on pitch and loudness and their connection to frequency response. In today's lesson, we'll begin by differentiating between pitch and loudness and learn what they correspond to in terms of waves. We'll then learn about the natural frequency of particles and solids. So far, we have studied how changes in velocity, frequency, and wavelength are interrelated when sound waves move from one medium to another. Building on that knowledge, we can now introduce how pitch, loudness, and frequency response further our understanding of sound waves and their interaction with different materials. Let's get started. To understand pitch and loudness, let us first recap frequency. Frequency refers to the number of sound waves that pass a point each second. It is measured in hertz. Crucially, the frequency of a sound wave determines its pitch. High-frequency sounds have high pitches, while low-frequency sounds have low pitches. For example, a whistle typically produces a high-pitched sound, whereas a drum emits a low-pitched sound. This difference in pitch is solely due to the difference in frequency. Loudness, on the other hand, is determined by the amplitude of the sound wave, not its frequency. Amplitude measures how much energy a wave has, and the larger the amplitude, the louder the sound. For example, an adult man whispering produces a quiet, low-pitched sound, whereas the same man shouting produces a loud, low-pitched sound. Similarly, a child whispering is quiet and high-pitched, while the child shouting is loud and high-pitched. As you can see, loudness changes with amplitude, but pitch remains tied to frequency. Now let's get into frequency response, particularly in solids. Particles in solids like glass, metal, or wood are naturally vibrating, albeit very subtly. The frequency at which they vibrate is called their natural frequency. When sound waves with a frequency close to this natural frequency hit the object, something interesting happens. The object starts to vibrate more strongly. This is known as resonance. For instance, if a sound wave matches the natural frequency of a glass, the glass will vibrate intensely. If the vibrations are strong enough, they could even cause the glass to shatter. The famous example of a soprano singer shattering a wine glass involves hitting a note that matches the glass's natural frequency. The sound waves transfer energy to the glass particles, causing them to vibrate more and more until the glass breaks. This demonstrates how an object's natural frequency can affect how it responds to sound. It's also worth highlighting that different materials transmit vibrations and frequencies more efficiently depending on their properties. For example, a metal rod may vibrate best at one frequency, while a wooden board may respond better to another. This is why objects made of different materials produce unique sounds, even when struck or playing the same note. Let's tie this to a tuning fork. When you strike it, the tuning fork vibrates at its natural frequency. This frequency is determined by the material and shape of the fork, making it transmit sound waves most efficiently at that specific frequency. Similarly, different musical instruments made from different materials resonate best at their own natural frequencies. This explains why two instruments playing the same note can sound so distinct, as each material favors certain frequencies over others. Understanding these concepts helps us better appreciate the complexity of sound and its interaction with different materials, enriching our knowledge of both physics and our everyday auditory experiences. In today's lesson, we delved into the concepts of pitch, loudness, and frequency response in the context of sound waves. We learned that the frequency of a sound wave, measured in hertz, determines its pitch. Loudness, however, is determined by the amplitude of the sound wave, with larger amplitudes producing louder sounds. We also explored frequency response, particularly in solids, and understood how when sound waves match an object's natural frequency, the object vibrates more intensely, a phenomenon known as resonance. By understanding these principles, we can better appreciate how sound interacts with the world around us, and why different materials produce unique sounds. Watch the rest of the GCSE physics course at Sophos Education.